We all have childhood memories of carousels. Sitting on a plastic horse hanging onto long metal poles as it spins you around and around with fairground lights zooming past you. These types of large carousels are usually powered by electricity. However, miniature carousels can be powered by a heat source as little as a candle. In this experiment, we will see how adding more candles, thus increasing the overall temperature, will affect the speed of a carousel by counting the revolutions per minute. The science behind this method of powering a carousel is from convection currents. Convection is the transfer of heat through the cyclical motion of air. When air is heated, it becomes less dense, so it moves upwards, with cold air going down into its place. The cold air is then heated by the heat source, and the process repeats. Here is how convection can power this miniature carousel. The heated air above the candles rise upwards, getting in contact with fans at the top of the contraption. The fans catch the movement of the air and begin to rotate.
Procedure. First, we set up the pole in the center of our cardboard base, poking a hole with a compass. We used a right-angled ruler to ensure the pole was perpendicular to the base. We then lit all 4 candles. We marked one of the fan wings with acrylic paint and drew a line on the base with a marker, indicating a starting and finishing point for each revolution. We then took several readings of the temperature of the air 10 centimeters above one candle. We used a ruler to ensure the distance was accurate and the non-contact thermometer to measure the temperature. The average temperature of the air above one candle was 59.4 degrees Celsius. After doing the math, we found that the total average temperature of 2 candles is 118.8 degrees, 3 candles is 178.2 degrees, and 4 candles is 237 degrees. Then the true experiment began. We placed one candle under the fan, seeing how many times it made a revolution. We concluded that just one candle was not enough to power this 2-gram carousel properly. Regardless, it made 7.5 revolutions per minute. We then added a second candle. The fan began to gain speed, being more steady than it was previously. It made 15 revolutions per minute. We added a third candle. We noticed a slight increase in speed compared to the 2 candles, but not that much. It made 23 revolutions per minute. We added a fourth one. It made 26 revolutions per minute, barely a difference from 3 candles.
Conclusion. In conclusion, our hypothesis was correct. However, the more candles we added, the more our acceleration decreased. When going from 1 to 2 candles, we noticed a very significant difference in the number of revolutions per minute. While going from 3 candles to 4, we barely saw a difference. Here we have plotted a graph with our results.